Okay, in this section, we're going to talk about bases other than e. So far, we've been dealing with everything in what we call a base e. The natural log function, we had a base e. We can have a base of anything. That's why we use, in this case, we use just any variable in a. Saying if a is a positive real number and doesn't equal 1, and x is any real number, then the exponential function to the base a is defined as a to the x equals e to the natural log of a times x. All right, if a equals 1, then y equals 1 to the x. 1 is a constant function. No matter what we raise 1 to the power of, it's still going to be 1. So that's why we say it doesn't equal 1. But we can have a constant function of 3 to the x power. So 3 squared is 9. 3 to the third is 27. You know how that's going to go up exponentially. So we're going to talk about bases other than just e. So a base, use similar laws as exponents. Anything to the 0 power is going to be 1. All right. If we multiply two things with the same bases, we add the exponents. All right. If we divide, so here's the adding one. If we divide, we subtract the exponents as long as they have the same base. So this is like saying like x squared all over x. Well, we subtract, right? So it's just going to be 1x. And same thing, a power to power, we multiply them. And that's number 4 there. Okay, one example of how we use this talking about the half-life of some material there. So what we have is the half-life of carbon. 14 is about 5,730 years. If 1 gram of carbon-14 is present in a sample, how much will be present in 10,000 years? Well, what we can say is we can say its half-life. So we can use a base of the half-life. So the half-life is every 5,730 years. So we could get a percentage of the half-life by dividing it by how much time has passed. Would you agree if I choose 5,730 years in for t and plug that in for my time, all right, I get 5,730 divided by 5,730. So I would have 1/2 to the 1 power, all right? Out of my 1 gram, I would have 1/2 of it left, and that's what we want. After 5,730, there should be 1/2 of it left. So that's how I set the equation up for that, all right? They want to know how much will be present in 10,000 years. Well, we're just going to plug in 10,000 in for t. So we say the half-life is going to be 10,000 divided by 5,730 years. And we can go and we can plug that into our calculator fairly easily. Go over here and we say 1/2. We put parentheses 1/2 to the 10,000 divided by 5,730th power. Okay. Enter that calculator, we get 0.298. So there's approximately 0.3 grams left of our original 1 gram of carbon-14. All right. So there is just one example of using a different base other than just our base e. The definition of a log function on your calculator, you've probably noticed that we have a log function just above your natural log function, and I can show you over here the log function right here. Okay. So the definition of the log function is if a is a positive real number not equal to 1, and x is any positive real number, then the logarithmic function to the base a is denoted by log a of x. All right, it's defined by, so if we have a log of some number, some base a, all right, we can figure out by saying 1 all over the natural log of a times the natural log of x. So the natural log, 1 all over the natural log of the base times the natural log of the number we have inside here. And the reason we have to do that is because on your calculator, your base for your calculator, if you can read what that says, it says logarithm to the base 10. All right, so anytime you type that in your calculator, it has a base 10 is what it's saying here. All right, well, we're going to use different things than just a base 10. All right, base 10 is just the real common one. All right, but we can use different things. We can use our calculator to find the log of 9 with base 27. All right, so then we can use our definition right here just to do that. We can say, okay, well, that's going to equal 1 all over the natural log of 27 times the natural log of 9. That's all we need to do is type into our calculator. All right, And you guys can do that yourself. We won't waste any more time showing you how to type that into your calculator. Just go 1 divided by the natural log of 27, and take that number times the natural log of 9. Okay. Log functions to a base a, so any base that we have properties similar to those of the natural log function. All right, as long as we have the same. All right, the natural log of 1 is always 0, just like, or sorry, I said the natural log of 1 is 0, and well, so is a log of 1. That's also 0. All right, we can break up, if we're multiplying inside here, we can break that up into adding. All right, if we have something to a power, we bring it down into the front, just like our natural log function. Again, if we're dividing, just like our natural log function, we're going to subtract. All right. Properties of inverse functions. All right, so the inverse, all right, the inverse of a, what it's saying is the inverse of a to the x would be the log of a. That would cancel those things out. All right. So those two are inverse functions, just the same as if I have the log of a to x, the inverse would be to raise it to the a power, all right, to the base's power here. Okay. So those two are inverses of each other. So here's an example. All right. The common log function is base 10. We've already talked about that. So here's an example. Example 2, solve for x. All right. They have 3x, or 3 to the x power equals 1 all over 81. So let's solve this here. What we can do is the inverse of 3 to the x power would be the log of 3, all right, of 3 to the x equals, if we do it to the left side, we have to do the right side. So the log of base 3 to 1 all over 81. All right, so we know that these cancel out, and this just becomes x. And we know how to figure out the log with base 3 of 1 all over 81. Well, we can go ahead and type in our calculator as 1 all over the natural log of 3 times the natural log of 1 all over 81. So let's give that a shot over here on our calculator and see what we come up with. So we would have 1 divided by the natural log of 3. Let's go ahead and put this in parentheses here. Oops. Sorry, struggling with that. There we go. Times, let's see, the natural log of 1 divided by 81. See what we get. We get negative 4. All right, so the answer for x then is negative 4. All right. And the same way, we can solve this. Well, this is saying log base 2 of x. All right, so we can raise everything to the 2 power. So 2 times the log of x, the base 2, equals 2 to the negative 4th. Well, these cancel out here. We have x equals 2 to the negative 4th. So we'd have 1 all over 2 to the 4th power. And 2 to the 4th power is 16. So we have 1 all over 16. Okay. So there's an example for B. I believe that's it. We're going to work in this first section with the properties. Yep. We're going to work this first section with the properties of the log with different bases here. So we'll see you in class.